today we have Steve Labuz with us. Steve is currently a hydrologist with the Water Monitoring and Surveys Unit at the Minnesota Department of Natural Resources. He received his BS from the University of Minnesota, Minneapolis, and did research on urban stormwater. And then he interned with us at the Metropolitan Council. So it's really great to have him back today. Steve received his master's degree from the University of Minnesota Duluth and focused on urban trout streams with cold water assemblage impairments. He began his DNR career in Marshall, Minnesota, and routinely gauges rivers and tweaks rating curves. Today, Steve will be talking with us about an effort undertaken by the Minnesota Department of Natural Resources to understand how accurately permitted water user reports how accurately permitted water users report water use, there we go, using acoustical flow meters. I've personally always wondered about the accuracy of reported water use, so I'm excited to hear about Steve and the DNR's efforts here. So take it away, Steve.
Thank you, Emily. And I'm going to minimize my my team's window, so I won't be able to see if there are questions for me in the chat or not. But yeah, feel free to interrupt me if you have a question and you want to ask it right away. I'm fine with that.
We'll keep an eye on it. Thanks.
All right, thanks. Okay, so hello. Again, thanks for the invite to speak at this group, and thank you, Carrie Robertson, for recommending me to Emily. I'm a DNR hydrologist in Joy Lockery's group, and this flow meter project started with Greg Cruz when he was the supervisor in 2018 or maybe late 2017. The goal and the title of this project and presentation is Measuring Reported Water Use. Okay, so this group is mostly environmental water monitors and use monitoring data for analysis and recommendations. So I included a couple of slides about the importance of monitoring. Although almost all scientists come to the realization that if they want their work to make a difference, then legislation will need to be passed. But lawmaking and policy and legislation is certainly outside of my wheelhouse, and for those of us who went to school for science, maybe outside of ours too. But as environmental changes occur, it's possible that these regulatory decision makings might be purposefully left flexible for adjustments. And since our agencies and groups are responsible for a large portion of environmental monitoring, we do in fact have, we can in fact, influence change. And it's the ambient long-term monitoring data that will have the most impact heading into the future. So again, environmental monitoring informs policy. It relies on this continued monitoring, and in the future, there could be a paradigm shift into adaptive management versus making a law and letting it stick around for 5, 10, maybe a couple decades later. And an example of compliant monitoring would be like a point source discharger who has to collect water samples to meet EPA standards, for example. Okay, so what does this have to do with flow meters? Well, those who pump more than 10,000 gallons a day or 1 million gallons a year require an appropriation permit. And they must report their water use and pump rate in MPARS, which is a water permitting and reporting system. This is both regulatory and ambient environmental monitoring. They're long-term data sets populated by the people who use the resource. A typical situation for an irrigator who reports an MPARS is this guy or girl installs this well, puts in a pump, and he gets the pump calibrated to 500 gallons per minute. And he doesn't edit this rate until the pump needs to be serviced. And additionally, every appropriation permit holder is different, and it's difficult to associate environmental changes to the action of just a few people. And this is a law that requires people who pump a certain amount to acquire these permits and report how much they're using. So Enter the flow meter study. The DNR collaborated with irrigation associations around the state. I'll get to the location later. This is a building sequence of slides here, so bear with me for a little while. The DNR collaborated with irrigation associations to install flow meters on center pivot pipes and to compare the calculated water use coming from these meters and the reported water use being reported in MPARS. Now, the benefit of this data was thought to be able to help with calibrate groundwater and water balance models in the area that we're interested in, and also improve relationships with irrigators. Another caveat to the, what section? To Minnesota Statute 103G 265 is that these permit holders need to report their water use within 10% accuracy. Yeah, and nobody's really checked on this before. And a special note about these flow meters and their data sets, I haven't found any other study or data set like them. Flow meters do widely exist in the irrigation world, but they're typically performed as spot measurements. There's a professor at NDSU, Professor Schur. He's considered to be, an expert in flow meters at their extension program, and he's collected thousands of spot measurements from irrigation pivots to help farmers determine their actual inputs to their fields, but he's never collected any continuous data from center pivot irrigators. So this could be an exciting study. So we have these flow meters on pivots, and our monitoring setups and the general physics of the flow meters look like this. The setup is much like a DNR stream gauging house, although the meters use a slightly different principle to measure water speeds. So in the middle of the screen, you see that there's this gauge house, and it's attached to either like a power panel or you put it right on the pivot. And you need a certain section of straight pipe. There's a logger in here, battery, regulator, and it's all powered from the solar panel to the regulator to the battery to back to the logger. And the logger collects, I'll get into this later, but water use, water speed, time it's on. And it does that by these two transducers. So the upstream transducer emits this ultrasonic noise, and the downstream transducer receives it, and it measures a transit time. And so there are a few different setups, but you need a certain amount of straight pipe in order to collect accurate data. So you want the most laminar flow that you can find. So the longer and straighter the pipe, the better. And a difference between like stream gauging equipment versus the things that we're using right now is that stream gauging equipment, like this Stream Pro on the left, it uses a Doppler effect to bounce noise off particles and return that to the instrument to measure like a frequency change. But ultrasonic meters send these signals into a pipe, and then it's timed by the downstream receiver, and it collects these different signals and it spits out numbers that actually make sense to water scientists. And this is mostly because the groundwater being pumped from the ground through the pivot is mostly particle free. So you can see on the right that there's some black splotches in the water, but that's mostly just an animation. And the Doppler effect relies on these particles in the water to bounce off this noise. But in a system where you have almost no particles, then that technique doesn't work, or it might not work as well. Okay, so we've determined that appropriators report their water use, but we don't know how accurate it is. And the DNRs decide to check the reporting accuracy of these meters, but how accurate are these meters that we're going to use? So before my time here with this project, 2 other hydrologists took these meters to St. Anthony Falls lab and compared them to other meters that they had in the lab as well as a flume. And the results were positive. So the conclusions were that they compared well within 2%, and that placement of these meters is especially key. St. Anthony Falls also has a spot flow meter, and it compared well to that spot meter. And on the right here is an image of one of the Simpsons episodes. I'm a big Simpsons fan, and it's where Homer and company form a vigilante group to protect the town against the cat burglar because the police wasn't doing a very good job. But when Homer starts to abuse his power, his daughter Lisa asks him, "Who will police the police?" And Homer replies, "I'm not sure, maybe the Coast Guard." So I thought that was funny. And a little bit applicable because, you know, we're asking these appropriators to monitor themselves. Well, you know, how do we know that they're reporting accurately? Well, these meters, how do we know the meters are reporting accurately? And so it continues. Okay, again, building upon our goals as environmental monitors. We know we have compliant reported water use, and we know that the accuracy is not being validated. And we also know that we have these meters that produce accurate results. And now we need to send these out into the field and verify compliance or maybe make some adaptations. So where did we choose? We chose Little Rock. The DNR published an action plan, sustainable use of groundwater in the Little Rock Creek area in 2018, I believe. And Little Rock Creek is also a groundwater management area. The watershed is about 50% agriculture, and 95% of the appropriation permits are used for center pivot ag. Yeah, so one of the reasons that this management area is of a concern because there's a designated trout stream with a cold water assemblage impairment with other impairments.
Hey, Steve, actually, I think we just need to mute somebody. Yep, keep going.
Okay, well, there's been such an increase in groundwater pumping. It's a concern because the groundwater use is very high compared to the flow into and through the Little Rock Creek watershed. So the stream flow is very low compared to how much water is being pumped out of the ground. For example, base flow at the outlet from 2018 and 2019 when this first study took place, about 15 to 20 CFS, and that's roughly 60 million gallons a year. And it's possible that individual irrigators could be pumping that much water onto their field, and there are around 40 or 50 appropriators in the groundwater management area. So another overview of the area. In 2018 and 19, that was the first 2 years of the study. We had 9 flow meters distributed throughout the area. Excuse me. And this year, 2021, there are 5 throughout Little Rock Creek. And on the left, the pink symbols are the locations of the meters, and the green squares are stream gauging locations. So land use has been altered significantly It's used for agriculture, and crops range from corn, soybeans, and kidney beans, but there are also specialty crops like sweet peas and potatoes. It's a very sandy part of the state, and which is what potatoes like, and potatoes also like to be watered constantly. So now we'll get into some of the results of the flow meters. Oh no.
Uh-oh.
Okay. Oh. Okay, this is it. Great. So this is on the left side. The dates got jumbled, but they're supposed to be. So the left side is year 2018, and the right side is year 2019. And they're busy plots with flow rate on the y-axis and time on the x. No data was collected midsummer 2018 due to logging difficulties, but there was a complete set in 2019. And as you can see in July, a couple notes to make about these graphs. July and August, looking at 2019, every irrigator studied was watering nearly continuously. There's an obvious gap right in the middle of the graph, late June, early August. And the reason why no one was watering then is because there was a rainstorm that dumped about 2 inches in the area, but relatively soon after and before, watering continues. And in both years, shown mid-August is about the end of the watering season with a couple expectations, and sometimes farmers in the area will put in cover crops after they harvest, and those cover crops are briefly watered. Also, the pumping rates between irrigators varies significantly, as low as 300 and 400 gallons per minute, all the way up to 900 gallons per minute. And it never really plateaus. So the farmer will turn his pump on, and it will vary between about 100 gallons per minute over the course of a watering period. And for scale, up here, where my mouse is, this is about 2 days, which is 1 to 2 days has been the average for how long someone waters in the area. So the flow meters, 3 variables were studied. Water use, which was reported by irrigators and MPARs, then compared against data collected from the flow meters. Pumping rate was again reported by irrigators and MPARs, then compared to the average pumping rate from the flow meters. Pump rates varied over the time of the watering period, like I just showed. And we also collected pumping time, collected by the flow meters and and compiled. Typo, pumping time was back calculated from the data entered in MPARs, and I'll show the comparisons soon after. Okay, so how did water use compare to what was being reported and measured? Irrigators reported water use volume in both years over-reported. 24% over-reported in 2018 and 25% over-reported in 2019. Pump flow rate, both years, again, showing an average of 23% overestimated in 2018 and 24% overestimated in 2019. Now, I tried to Google image a smoking gun to show where the problem was between inaccurate reporting. And apparently, smoking guns are culinary tools, which I did not know existed before this week. So you can put smoke inside of some apparatus or sealed dome, and you can give it a smoky flavor with that thing. So these are just some tables of data summaries. And almost every irrigator, with a couple of exceptions, overreported their pumping rate, gallons per minute. Again, a typical situation after talking to these guys is that they have a pump that they installed 10, 15 years ago. They didn't see any problems with it. You know, it's been producing water. They've been collecting a decent harvest. They've had no reason to look into the performance of their pump. So they leave it and it decays, loses efficiency over time. And also, water use is being overreported. So in 2018, the meters measured between the 9 irrigators, 65 million, and what those 9 irrigators reported was 80 million. Those are million gallons a year, millions of gallons. Again, in 2019, 102 million gallons were measured, but 130, 129 million gallons were reported. There was a guy up here, I'm forgetting the number, I think it's 41, but the results were shared with him after 2018, and he applied a efficiency factor onto his water use the next year. So he was very close. He went from 30% off to 6% over reporting. Pumping time. So on average, an irrigator is reported to run his pump 341 hours, which is almost a little over 2 weeks. And the flow meters reported an average runtime of 350. This is a 2% overestimation from irrigators. So this shows us that irrigators their method of reporting is accurate. Yeah, so pumping time. Given the data and knowledge, appropriators have their system, their techniques they use to calculate the water use is accurate. Reporting pumping time was back calculated. I'm on the wrong. Reported pumping time was back calculated using their water use, which was volume, gallons, and their flow rate, gallons per minute. So with those two, we can get a time. And measured pumping time was a summation of valid data from the flow meters. So a couple of sources of error. Again, to summarize the results, irrigators seem to overestimate their pumping rate, leading to an inflated reported water use. Their method of reporting water use seems to be accurate based on reported pumping times, which match closely with measured pumping times. A source of error, comparing monthly water use values are difficult because irrigators may have different scales of what a month is, because some of them use their energy bills to calculate their water use, and the energy company might start the month on the 5th. Others may not use calendar days. They'll consider day 1 is the first day that they pump. And others will take the yearly total and divide that total evenly into 3 or 4 months of watering, even though they may not watered at all in May or June. Information such as pump age and electric bills, this is private information. And I was trying to pry one of the participants for his energy bill just because I wanted to validate the information that was being reported. And rightfully so, he was slightly defensive about giving up any of his private information. And another source of error, which could involve 1 or 2 or 3% error, is installing and programming uncertainties. So when you install these deucers, it gets hooked into a logger, and you have to program the logger before you can read any valid numbers. And the logger asks you for things like roughness of the pipe and thickness of the pipe. And those two things are mostly uncertain. We're reading tables, we're looking up specs, and sometimes we're calling the irrigator themselves and asking for their opinion of the outside diameter of the pipe and saying, well, typically it's a 1/8 inch thick, but we know that outside diameter is slightly higher than what he said it was, so we have to adjust our numbers there. And the spacing between the loggers also needs to be precise. So after we make all these inputs to the logger, it will tell us the spacing that we need between the two transducers. And we can mark out with a Sharpie, precisely what it needs to be. But when you tighten the meter onto the pipe with a lubricant on the pipe and on the meter, there's always a little bit of slippage. So it's not as precise as you'd like it to be. Future ideas. Again, these data sets are pretty unique. A lot of people just will take a spot measurement to see the efficiency of their pump. But we have the chance to take some long-term monitoring on these pivots in different areas of the state and perhaps measure pump rate decay. Another idea would be to ask for more information in the MPAR system. And with that, I'll take any questions.
Thanks, Steve. That was really useful or interesting. And I'd encourage folks to put any questions they have in the chat. We do have one question in the chat, but I thought I'd first ask a question myself. Could you clarify how this was a double-blind study?
Yes, thank you. I think I skipped over that point. So we went out in the beginning of the year, we installed these meters, and we did not share any of our results with the irrigator until they reported their numbers in the MPAR system.
Okay, so they all knew that they were participating in the study, though.
Yes, they all knew. They all signed access agreement forms, and in this picture, it's not uncommon to be driving down field roads with rows of corn 7 feet high on both sides. So this is private property.
So do you have concerns that these participants were really trying to behave and report accurately because they knew that they were being monitored?
I don't think they could have reported. I don't think their reporting accuracy could have changed. That's a good question. I left a slide. So this is an image of the different methods that irrigators use to report. And the only difference between all of them is pretty much their timing device. So they really had no way to calibrate their pump rate without these flow meters. All of them we talked to, they hadn't had their pump rate calibrated. They had it calibrated when their pump was installed, but not until we arrived on site. So the only thing that could really change is their timing device, how long they know that their pump was running.
Okay, so they're required to use these methods. They could completely make something up, but otherwise, if they're using this method, that's the only way they can do it. So John Clark has a couple questions. Whose responsibility is it to ensure the 10% error standard is met? The DNR, the permit holders, or both? I think you talked about this a little bit, but maybe expand a little.
Yeah, I cannot answer that question with 100% certainty. The people I've talked to who are most vested in the MPAR system are area hydrologists who routinely work with the irrigators and appropriators.
Okay, thanks. And then is there a reason why these pumps are not metered? Is it cost, logistics? Could this or a calculation standard protocol be put in place? Could everybody have to have a meter?
Yeah, these meters are quite expensive, and that's one of the benefits of using a spot meter if you have a large scale farm where you have a lot of center pivots, is that you can buy one instrument and calibrate your pump, every single pump that you have every year. The instruments that we were using stay on one center pivot all year long.
And are those spot pieces of equipment, are those recommended or to irrigators? And do you get a sense a lot of them have them?
No, I do not get a sense that a lot of appropriators have these spot measurement irrigators. There are a couple SWCDs in the Little Rock Creek area that do have them and will make visits to irrigators and help them calibrate their pumps.
Got it. No, that
But
sounds like
these meters they're over $1,000 each. And so for a farm who might have 10 or 12 center pivot pumps, it's not economical to put one on each pump.
got it. Jeff Anderson asks, have you reached out to any of the pump manufacturers and asked about calibration drift, rate decay?
Yeah, so that's another great question, is determining, if you can apply some blanket efficiency factor to the age of a pump. And that's a part of this future idea, is that you can put these meters in different areas of the state and measure the average decay of pumping rate, because these manufacturers, they might say that, oh, well, your water is very hard, and so there's a lot of precipitate moving through these pumps, and that's wearing on the pump much faster than it would if it was completely void of any solids. So it has a lot to do with the groundwater geology.
Really interesting. So I have another question. You started out talking about how data can impact policy. Do you have a sense of whether the outcome of this study is likely to result in any policy changes?
Yeah, so there was a groundwater model made for the area, and this study was to, help confirm or try to was for an input into the groundwater model. And what ended up happening for the withdrawal input was that our modeler ended up using the values on MPARS. So he deemed those values accurate enough.
Got it. Are there any other questions? If you have another question, feel free to unmute yourself and you can ask. Oh, John has another. Do you know if the DNR or another entity has considered a shared cost program to meter all the pumps in the state?
Yeah, so, okay, so they are slightly metered. You need to have like some sort of way of being able to tell when and how long the pump was running. So they're metered in that way, but they're not metered in a way that can measure water speed going through the pipe. And I do not know if there's any legislature going to be passed or looking to be passed to make that a requirement.
Got it. Thanks. Any other questions? Like I said, feel free to unmute yourself if you have one.
Hey, Steve, this is Jen Kostrowski. I have a question. Do you guys have any other intentions or any other ways that you're hoping to share this information of what you've learned with folks, and so that more water resource professionals, or in this case, I guess, or farmers would have access to your study findings?
Yeah, I did write a report on the 2018 and 2019 study. It's on DNR's website, and Emily, I can send you that link after this presentation if you want to distribute that. But overall, I am interested in a way to figure out how to use this continuous data set. Like I said, it's very unique among the flow meter community.
Yeah, agreed. I hope that you get to share this with as many people as you can.
Yeah, if you would send me that link, I will post that with the video on our website. So that'd be great.
Great.
Looks like that's probably it for our questions. So I think we can wrap things up. I want to thank you, Steve. This was really interesting. We usually are dealing a lot more with water quality in this group. So it was a refreshing change to talk about water quantity and look forward to seeing how this study is maybe used more in the future. So thank you so much for joining us. And everybody have a good day.
Yeah, thanks for the invite. Have a nice day, everyone.